Okay, welcome everyone. We're just going to give it a couple more minutes here as we got people filtering in. Really excited to have you join us today. Okay, I'm going to go ahead and get things started off with a quick intro, and then we'll jump right to the webinar. Welcome everyone. Really appreciate your participation today and joining us today. My name is Mike Person. I'm the program coordinator for the Great Lakes Biochar Network, and also going to host today's event. Also with me is Amanda Curtin with GLBN, and really appreciate her involvement. She's going to be handling some of the behind the scenes things. So before I pass it on to John Bradburn and Mark Mersman with OFX EcoSolutions, I want to kind of go through a couple quick things about this event and actually our future. The intent of the Spotlight Series is to basically give individuals engaged in a variety of biochar enterprises, be it business or research or whatever, those are doing unique or interesting, innovative biochar work that has relevancy to the Great Lakes region. We want to give them an opportunity to spotlight their work. And there's a couple rules, a couple goals that we're really trying to accomplish with our Spotlight Series. And one is education. We want them to be educational. And two, provide opportunities for facilitating connectivity amongst all the different practitioners in the biochar space these days. So those happen to be our two fundamental missions here at GLBN. We're working hard to be a centralized hub for relevant biochar information in the Great Lakes region. And then we'll also see our role as a really important role to provide those opportunities for connections amongst all the different people engaged in this sector these days. So a couple of quick housekeeping things for today's event. We'd really like to encourage everyone to engage with us on the chat function as John and Mark are giving their presentation. Please go ahead and put your questions in the chat box, and Amanda will be monitoring those things, and then we'll come up after the presentation, and we'll have a little session for Q&A. And then at the tail end of the event, then I'd like to come back, and I got a few things I'd like to go through specific to our work here at GLBN. So really excited to have John Bradburn and Mark Mersman with OFX EcoSolutions. I think they really give a unique perspective on biochar production, and particularly as it applies to production, feedstocks, and potential products related to biochar. And I'm also really excited to hear an update on their work with invasive species and how that may be a potential feedstock for biochar and ramification or potential implications for the Saginaw Bay, in Michigan, Saginaw Bay, which happens to be some of my stomping ground. So really interested in that. So without further ado, Mark and John, if you want to go ahead and take over and start the presentation, I'm really looking forward to it.
That's great. I think everybody should be able to see my screen at the moment. We good? Excellent. Well, thank you, Mike. Thank you, Amanda. Thank you for everybody who's joining us today to talk a little bit about pyrolysis, gasification, and biochar in a total systems approach. OFX EcoSolutions is my slide's not advancing. Is a company built about 3 years ago with a group of globally recognized professionals that encompass zero waste systems, oil and gas, environmental law, renewable energy, and finance. And we've all really collaborated around an initial idea of focusing on plugging oil and gas wells that were orphaned and capturing that carbon. But over the course of 3 years, John Bradburn and I, along with our other two partners, Don Boyder and David Briggs, our two resident geologists, have really evolved quite a bit from that original focus on, okay, let's just focus on oil and gas, identifying and realizing that this material biochar is quite incredible and has so many capabilities for remediation and reclamation. Bringing John into the mix after Don and I had met, and Don brought Dave in, and Dave brought John in. We realized there's a much bigger issue to be addressing, and that is, how do we handle so many different problematic waste streams? Really taking those waste streams to their highest and best use. How do we really optimize all of the touch points within a complete value chain? And we'll touch on that in a minute, and really make the most out of that. So with that, we are now no longer just focused on oil and gas. We've been blessed to be able to be consulting with and working with multinational companies, state and local governmental entities, in universities, really addressing all of the different attributes of particular more problematic waste streams, and what are the ultimate end uses that we can do if we take those materials through this process. So the idea of a total systems approach isn't really so new. John's been practicing it for a big chunk of his career. A little bit of setting up John for 40 years or so. John was with General Motors over handling global waste. And in the last 25 plus was focused on bringing over 150, roughly 152 plants worldwide, zero waste to landfill. And what we see with pyrolysis and gasification is it's a beautiful tool to incorporate this type of an approach, a whole ecosystems approach. And in doing that, we thought we'd start really with a real life example and just share what we mean by this. And then we'll walk through how gasification and pyrolysis, biochar, all really fit into addressing some of these really significant environmental challenges that we have globally, and problematic waste streams that companies are really trying to figure out ways to handle in a better way because they're being forced to. For the environment, for financial situations and needs, et cetera. So with that, John, if I missed anything in that, please fill in any blanks. But John's going to share a little bit about what he and David did a few years back, which is just an incredible example of where a total systems approach can be utilized.
All right, yeah, thanks, Mark. Hi, everybody. Glad you could participate, and hopefully we do this justice. Yeah, 40 years at GM. I was born and raised in Flint, Michigan. So I'm a Michigan kid. And we'll be talking certainly about invasives and, the Saginaw Bay. I was half raised there. I spent a lot of my time as a youth there and as an adult as well, and have some property there. So, which includes a wetland. So this really became an opportunity when Dave reached out to me, Dave Briggs, because in managing GM's waste, I always looked at, okay, what's traditionally available to manage a particular material, not a waste, but a resource. It's a byproduct. And how do we take these byproducts and put them to a better use? That really became challenging, but at the same time, it included traditional recycling, included repurposing, reusing. And in this particular case, how do we understand what's available out there, and how can we make the greatest impact? I look at it this way. In our lives, we've only got so much time. And for those who want to make the best use of their time and create the biggest impact and really to make society better, how do they incorporate things into what they do? And it's kind of like that old saying, keep things simple, stupid. Many of you have probably heard that. Well, I say keeping things simple is stupid, because you can create a program or a project and make money and do many other things. And that's what this one did. Telling the story is important. This story was in 2010, but it lived and happened from 2010, 11, and 12 You see the Chevy Volt there. It was the green car of the year in 2010. And this is one reason why it was proclaimed to be that. It was because we went down there. Dave Briggs was in the Gulf working with his technology. That's the second slide there. We worked with Heritage Environmental to collect the boom that was used to pick up the oil-soaked booms with seawater too, of course. We then compounded those once those were centrifuged using Dave's technology with other plastics. The picture on the top right will show you that, and that included tire crumb. It included post-consumer plastics, polyethylenes, and we created a engine over the engine. The Volt had an engine also. It was battery powered, of course. That was an air management baffle, and again, three model years. So this was many vehicles, and we had a lot of material to work with too, because it was 212 miles of these boom that were recovered and put into this program. And that's kind of where we're getting at with a total systems approach, but it goes farther than that. It's also about understanding how you can impact many things. And I'll just name a few that I think related to this project that are the UN Sustainable Development Goals. Good health and well-being. For those of you familiar with those SDGs, education, educating people about what's possible, even with a challenging material like that polypropylene material that was inside those booms. And just to give you a little factoid data, over 500 million people knew about that project when it happened and shortly thereafter. So telling the story is very important. A good project's not complete until the story is told. That's because it can do more good, and it teaches people how important it is to, do these sort of things. How about clean water? Certainly a big deal there in that particular instance. Innovation, quite innovative, I think, being able to pull that one off. Responsible consumption, climate, life below the water, partnerships. All these sort of things relate to the Sustainable Development Goals, and it is a total systems approach. So at OFX, that's what we try to do is, how do we do a project that includes biochar and capitalize and utilize all those various resources that come and can be impacted in a favorable way within that one project. So that's the example. Okay, Mark, if you would please flip aside. Yeah. Next slide shows what most of you are aware of, biomass, woody species here. A lot of times, as you know too, invasives themselves will take these trees out, or they'll age out, or just lumbering, in fact. This is a renewable resource, wonderful resource, whether they be turned to lumber or any slag, any offal, any slashings, and those sort of things are recovered as well. And we've done some experiments, as Mark said, worked with some universities to take some of that material and turn it into biochar. This is a great resource for biochar, especially, again, if you can look at it from a perspective of what's currently being done with it and how do you take it to that highest and best use to benefit society, to benefit the ecosystem and the wildlife and the habitat and so on. So that's what we're looking at. That's one of the areas that we're addressing. Okay, Mark.
Yeah. So with that, I think John touched on offal and so many other different materials fit into this. And given the audience, we weren't quite sure how deep to go into actually the process of biochar and making biochar, what that really entails. So we're just going to hit on this at a very high level. We can come back with questions later on, but we'll get through this component. Biochar really is a process. It's the material that it comes out as a byproduct of the process of pyrolysis and or gasification. So we're agnostic on the technology. We have one pyrolysis unit that's a pilot pyrolysis unit right now for small trial batches and things of that nature. But what basically is happening, we're taking biomass of any type, whether that's woody or biologic, any number of different types of materials can go through the pyrolysis or gasification process. And pyrolysis is really just burning that material in the absence of oxygen. The byproducts that come out of it are where the value chain and the total system really, really sing, in that you not only are helping repurpose a particularly challenging waste stream, but from that process, you can create a number of different byproducts: renewable fuels, syngas, electricity. We'll touch on those in a minute, but biochar as well. And what we know is that depending on the type of feedstock and the type of technology being used, it's dramatically different from one biochar to another. Resonancy rate within the same system makes a difference in what the end product is on that biochar production. So what you see here, we believe this is an image of rice hulls being turned into biochar. This is more exemplary, I think, of a woody type biochar magnified significantly. And what you find is biochar is this carbon material that has an immense amount of pore space and surface area. And as we figure out technologies and we figure out different applications for different waste streams that are put through this process, we know that there's multiple unknown and known uses for biochar in a total systems approach. So what does this mean in terms of a traditional view? A common term out there is a value chain, where throughout the process from start to finish, there may be different components within that value chain that do create value. So I'm going to talk about this piece, then John's going to really throw all those other various attributes that turn it into a total systems approach. And I think what's critical is just kind of take a simple example. We've got feedstocks out there. We need to throw something through the pyrolysis machine. There's a tremendous amount of different types of feedstocks that are a problematic waste stream that need to find a new home, rather than a landfill, as an example, or just sitting in the forest decomposing. So what you can sometimes find in the different region that you might be operating in is that there are tipping fees available to take certain types of waste streams into this process. That company A is trying to figure out a better way to disposition this particular material. They may pay for you to take that material out. Avoided emissions are a nice benefit too. So as we look at some of these different types of materials that are just sitting in the forest gassing off, well, if we can turn those into biochar through that pyrolysis or gasification process, we stop that emission rate. Nature-based credits are now becoming more and more viable. And through the process of eradication of particular invasives, you may be able to pick up or develop an environmental credit through various agencies, both governmental and voluntary. And there are a tremendous amount of grants and tax incentives out there right now that are promoting our collective encouragement to really start addressing some of these environmental challenges, and in particular these invasive species and other problematic waste streams in our environments. So we've got the material, we've figured out how to get that into the system in a way that seems to pencil out okay. Whether or not you use pyrolysis or gasification, again, we're agnostic to that. It is a function of the material we find more than anything, and really what the end result might be, what the byproducts you might want would be. But through that process, we know that we can create heat energy. We could potentially create renewable electricity. We could create green hydrogen. Those are some of the projects that we're running down the path towards right now. And carbon removal offset credits. So we don't dedicate a lot of time in the presentation to talk about the credit piece, but in Q&A, we can certainly touch on that quite a bit in what constitutes a credit and how biochar can be produced to generate one of those credits. So we've got this value chain, we've got these things happening. We've avoided dispositioning into a landfill with a particular waste stream, so that's a benefit there. We've taken it, we've pyrolyzed that material, we've created some electricity, let's say, and yeah, we've got biochar. And that material is creating a biochar that might have a very specific use case that it's best for. We know biochar at large can absolutely be used in soil amendments and remediation, reclamation, water retention. We know it can hold water in soil. So in more arid climates, it can be a wonderful amendment to maintain moisture in our soils. On and on and on. We're learning more and more about that. And okay, where does the revenue come from that? Well, this is one of the bigger challenges of the industry right now. It's a nascent industry. And what we're finding is that there's more interest in generating the biochar than there is in figuring out ways to utilize it economically. And what we see in the value chain, and what we originally started from, was a perspective of, where can we use these materials? Where can we develop a demand? And then we've backed into, we're now starting to look at different ways and different types of pyrolysis and gasification, and geographically where we may be locating some of our own facilities at some point, but that's not critical at the moment. That said, we know that oil and gas reclamation, there's over 3 million orphan oil wells out there that need to be addressed. The team here has a unusual exposure to oil and gas from an environmental perspective, and we're all very passionate about moving the needle forward on that particular cause. And biochar is a fabulous amendment with adsorptive capabilities to absorb hydrocarbon materials, just contaminated soils and things of that nature. We've got an image that we'll share with you in a little bit that just shows where the potential is in utilizing biochar and reclamation. So I'm touching on the value chain here, really the common lens to how we look at a system. John, share a little bit about how, and you touched on it a second ago, about here throughout this whole process, we're really able to lean into a number of different benefits, and how do we weave them all together? So.
That's right. Yeah, Mark. So part of this includes trying to understand if a condition's addressed through biochar, utilizing some of those things that you've seen, those line items that Mark just showed on the previous slide, which is good, very good. However, why don't we make it great? Let's go from good to great. Let's look at the benefits, the total systems approach, relative to human health and the environment as well. And that's where it leads into some of those things I mentioned before with the New Horizons oil spill project we did. And I won't even mention those at this time because, you know, we did earlier, but how about additionally, what if we did a project that impacted, poverty, hunger, affordable energy, decent work, economic growth, sustainable cities, life on land. These are all UN Sustainable Development Goals as well as those ones I mentioned before, of which could be incorporated into projects. You know, wildlife, for instance, when we look at doing a project, particularly with Phragmites, just a harvesting of them, as well as what are we going to do with them, is certainly going to impact wildlife. And we want to make sure that we do it favorably. Phragmites, for instance, doesn't have much of a wildlife value. Most people recognize that. But at the same time, you know, what if we harvested them and then replaced it with native species? And those are the sort of things that we're doing. So we don't have this program and these various projects figured out to the point where we're going to say we're done where we're at. We're going to keep evolving them and keep improving upon them. And as you can see here with this list, it's even growing bigger. And again, it complicates things, but it also improves things. So as many of you would know, if probably all of you know, sometimes a problem is tried to be solved and another one's created. That is what we're trying to avoid. How do we continually improve our ecosystems for humans and as well as all the other life forms that exist along with us? So that's the difference between those two slides, one Mark showed and the one I'm talking to. Okay, Mark.
That's great, John. So what we'd like to touch on is just a really high level view of a total systems approach pilot that we're initiating. It's still in its early days, so we're being really high level with this. But as we all know, there is a number of challenging. Sorry. There are a number of challenging invasive species around the Great Lakes watershed. And what you're seeing here are three of those. We've got duckweed at the top left, we've got autumn olive in the center in the top right, and then our lovely Phragmites. So John has, I think, 3 wetlands, but in particular has been involved on at least one of them in trying to eradicate Phragmites from Australia, the invasive species type. And we believe that there is quite the opportunity here to work with our community in addressing how best to eradicate and pull the Phragmites out of particular areas and take them through this whole process. So John, I'll let you kind of touch on your experiences in dealing with Phragmites and where we see things going. And we'll take it from the start and we'll take it to what we're doing in oil and gas. We'll talk a little bit about that.
Yeah. So, yeah, Mark, thanks. So I don't know, most of you probably heard of that saying, if you believe that, I got some swampland I can sell you. And actually, if you know of some swampland, send them my way because I buy it. What you're seeing on the bottom is my wetland. And you're seeing the Phragmites there, and that is actually showing more daylight than you would normally see. When in the green summertime, you can hardly get through there. In fact, you can't. You're going to get lost maybe, unless you're real close to the road. But the reality is it's been improved upon. The Phragmites have been about 80% removed, and some of those been collected and working with some fantastic entities right now. Very interested in invasives, and those include people on the Saginaw Bay. So that and then the frog bit, in fact, on the top left, harvested some of them, set them out for analysis. Actually was part of a white paper, peer-reviewed academic journal article that measured some of the properties of that frog bit. And so that's really at the level of some of this work that needs to be done to find the best home for the material, as Mark mentioned, and dealing with byproducts, I'll call them, resources out of place. Over all these many years, that has been the biggest challenge. How do you find a good home or the best home for it? You'll find a lot of entities, companies, so on, saying, hey, who wants my stuff? But the key, though, is to finding somebody that wants it. And in a circular way, it's most likely best. Each situation is slightly different. And in the Phragmites side, we think we got some pretty good solutions lined up. And those can include some of the ones Mark has listed on the slide he showed, filtration and agriculture and those sort of things. So that's kind of where we're at on that one. Okay.
Yeah, and I think that's where when we're looking at this is one problem, a challenge that we're trying to find a solution to. And these are immense in number, right? So there's a tremendous amount of opportunity for all of us to be out thinking through, okay, we've got this particular material. John hit on a really important piece, and that is in collaboration with Indiana University, we have been able to look at what are the attributes of these different types of materials in a microscopic way as it relates to the biochar that it produces. And there's an energy component to that too, where there are certain materials, certain biomass that has a higher BTU value than others. And in that, there is a big push economically right now from incentives, just sustainability and resilience, that we need other sources of renewable energy. So biomass to energy programs are really taking off, and there is an awful lot to learn about how best to utilize different types of feedstocks to optimize a particular system. Well, then that leads to what's the end result? What is that material best utilized for? We're finding that some materials are ideal for electric conductivity, batteries, things of that nature at a very high tech level, which is really exciting. That's just carbon. We know carbon does an awful lot of really amazing things. On the other side of that, we know that there's other materials being made with higher silica type biochar. So rice in that regard has interesting and unique properties, and that it's got a high silica content. There, at a microscopic level, are some materials that are more likely to be better utilized for absorption of particular metals, and on and on and on. So what we've been endeavoring to do is really, with the purchase of this little bitty system, it's called Rocketchar. Rowdy Yates manufactures that. Little plug to Rowdy. He's been super helpful with us. And yeah, we've been able to really take some of these materials and really explore what the attributes can be, how they can benefit different types of end use applications. And one of those that we started with to begin with all of this was, how do we address this kind of a surface area? How do we help lean into the reclamation of oil and gas well sites, and do so utilizing biochar to help improve the soil health and remediate and reclaim these areas that have been contaminated for 50 years, in many cases 70 years, with hydrocarbons, waxes, paraffins, all kinds of other things that contaminate the surrounding area. And we're very excited about that. We have some early dialogue around pilots to where we can not only utilize biochar, but there's an awful lot to be said for inoculating biochar with microbes and other things that help that biochar attract certain life forms or particular elements. So there's an awful lot to research here. We're really excited about some of the university affiliations that have agreed to start researching soil amendments in that regard. There's an awful lot of research like this going on all across the country. And I think that leads nicely into one of these bullet points is we need collaboration in R&D. There's just a tremendous amount of research and collaboration needed. It's an immense challenge that is our environment at large, and pyrolysis, gasification, and biochar can be a really helpful tool in providing solutions. So what we know is we can convert and divert problematic waste streams like Phragmites and sludges from food processing companies. All kinds of different things in that regard can be viewed with an eye towards what happens if we go through pyrolysis or gasification of that? And what is the byproduct of that? And where could we use that to further impact? Biomass to energy is a very, very important trend that is getting a lot of capital and attention from the marketplace, from federal agencies as well. And what we know is that with that research, we can create different biochars for different applications. Various types of feedstocks create various types of biochars that have different and unique applications that they're best suited for, such as agricultural nutrient reduction. Can we capture nutrient runoff and then reapply that nutrient? Maybe. It's an interesting thing to explore. And same with water filtration systems. There's PFAS studies. The EPA is working with a number of biochar manufacturers to explore how biochar can reclaim PFAS from water treatment plants. That's just a huge problem that needs to be addressed, and biochar seems to be positioned wonderfully to be a solution to that. And from an incentives perspective, there's an awful lot of tax credits and voluntary carbon removal credits that are tied to the production of biochar and or utilization of these gasification and pyrolysis units, that if we are converting that biomass into energy, that there are some really significant grants and tax incentives from an investment perspective to promote that adoption. So I think the last thing to land on, what John's been hitting on, what we feel is so important too, and that is for greater corporate adoption, we've got to be providing solutions that do check the boxes for these UN sustainability goals. And more banking institutions are demanding that their banking clients are making strides towards reducing scope 1, 2, and 3 emissions, which is the E of the ESG component. And so many other pieces to the environmental concern of ESG. Yeah, this whole process, and wherever you might line up in that value chain, or if you're taking a total approach, we create a number of benefits that we refer to as co-benefits. And we really see the value chain and the ability to stack all of those co-benefits into making all of this process that much more economically viable and attractive to corporations who are maybe a little bit more reluctant to make any kind of big commitments to ESG or try to really have an impact. So we think that helps pull the market along with us. So with that, I'll
Yeah, hey,
I'll let
Mark.
John fill in some spots there, I'm sure.
Well, yeah, I mean, we obviously we've got a lot we'd like to talk about, but we certainly want to keep the Q&A all open and, you know, have an open dialogue here. But just one point is the collaboration bullet there, in the filtration piece of it. You know, to take the collaboration discussion to the next level. If anybody out there is generating biochar that they think could reclaim nutrients, we'd be interested in talking to you. We'd like to incorporate local stuff that is, you know, Michigan, Great Lakes kind of stuff, and particularly phosphorus. If you've got some biochar you think you can, that is inoculated or charged to the point where it could do that, give us a call, and there's our emails right there, and you know that relates to some of the work that we're currently working on.
Yeah, that's great. Mike, Amanda, I think we'd be good opening it up for questions if everybody's ready. Oh,
yeah, that sounds good. We've got a couple questions here in the chat. The first one is, I have manufactured biochar in my backyard. I have used the activated form with the compost in my flower bed. I want to sell the biochar I make. What are typically the steps I follow to test the quality of biochar and determine the cost of biochar? If I want to sell carbon credits related to biochar production, how should I typically go about that?
Yeah, good question. John, you want to take the manufacturing piece? I'll hit the
Yeah,
carbon.
I'll start it. Yeah, and then you can finish it up and provide, you know, other backup detail. Yeah, that's where we started. That's where I started. You know, just built a retort out of cement block, and put the stack on it and let her rip. And I made biochar. Now, you know, there was probably a fair amount of ash there and that sort of thing. And then I upgraded it to an old steel fire hose cabinet, put a stack on it and a thermometer off a barbecue grill. I mean, that's how it started. As of, I don't know, a year and a half ago, I hadn't even heard of biochar till Dave Briggs reached out to me, you know, and then Mark and Dawn and we all started talking. So first steps are first, and that is, you know, that is the technology that created our first biochars. And that may be what you have there. But then we, as Mark mentioned, purchased the more sophisticated, very much more sophisticated unit, that rocket char unit that Mark mentioned and built. But, you know, as far as, you know, producing it on, I don't know what kind of unit yet, volume, scale, and that sort of thing. But that certainly, there's some certification programs out there Mark can speak to a greater extent than I can. And it is an opportunity, and it's doable. But Mark, why don't you take it from there?
Yeah, it's a great question and an ambitious one too. I appreciate the approach, and that is an entrepreneurial spirit is required for solving a lot of these problems. So I commend you for taking the initiative. Scale is a challenge. The industry is awash with non-certified biochar, where there are facilities that just produce it to eliminate their piles of wood waste if they're a lumber yard, as an example. Many of those companies that are processing that biochar are not doing it relative to the IBI, International Biochar Initiative, has a guidance, USBI as well, in conjunction with that, on what constitutes biochar technically, and that's an important certification of what amount of carbon is in it. The credit component gets quite complicated. There are very stringent methodologies for the production of the biochar, focused predominantly on what is the feed stream and how renewable is that, making sure we're not using like railroad ties as an example. Are maybe that's not the perfect example. There's certain materials that do not qualify for renewable in the sense of creating a carbon removal credit. So that's one piece. The second is the system within which you're operating. There has to be an ability to really dramatically, if not completely, reduce any emissions of VOCs. And it's that piece that is so critical in providing a certification to the producer of biochar. That's where the carbon credit is awarded. So if you're processing and making your biochar per spec to Puro or Carbon Future or Vera, there's the EBC standard that is adopted by Vera. Those methodologies have to be adhered to. You would go through a certification process with the organization of your choice. They would certify that that process does meet those standards. And every ton of biochar that you produce then would be tested. Any number of local labs can test the carbon content and the other attributes of that biochar, to touch on that question. Local universities, if you have a university that you have an affiliation with, they could test the attributes of that biochar for you as well. But depending on the carbon content of the biochar, on a per ton basis, as an example, so 1 ton of high quality woody based biochar has upwards of 80-90% carbon in the biochar, whereas a rice or a bagasse biochar may only be 40 to 60% carbon. That carbon content is what drives the calculation for how many carbon credits that would be created if compliant in the process, that would be awarded to, as just a simple measure, 1 ton of biochar would equal 1.5 tons of carbon credits and carbon removed. So an interesting component about these carbon credits related to biochar production, it's counted as a carbon removal credit, not an avoidance credit. And the marketplace awards a much higher value for carbon removal projects than avoidance projects. So I've said a lot there. I'll stop and see if there might be some follow-up questions to that. Hopefully that helps though.
Well, I might just add, Mark,
Oh.
you know, if a person's just gonna use it in their garden, I'd say that's great. That's great. I'm doing, you know, and if they're gonna, you know, offer it on a business scale, then yeah, then you got to be a little careful there in terms of, you know, what the claims might be made or how it's commercialized. But you know, what Mark's speaking of is certainly on the commercial side and that side with some volume associated with it. But just to make some in your backyard and utilize it in your garden and maybe a little beyond that, there's going to be some benefit there.
No doubt.
Okay, great. We have another one here. Are there markets for the syngas bio oil that are created alongside the biochar? Do they require any further processing before being used for energy?
Yeah, very, very good question. And not a super simple answer necessarily. John, would you like to touch on the scientific component of that? What can be created as byproducts and why one material might be different than another?
Yeah, it's a really, really wide gamut, you know, and not my area of expertise, but I can tell you not all syngases are created equally. You know, that it had to be analyzed and then, you know, condensed and so on, further processed in most, if not all cases. The heat though, the heat itself generated from, well, for instance, that rocket char unit we got is massive because it consumes part of the feedstock that is that's its energy source, is part of the feedstock, and then it burns those gases to produce a very clean exhaust and tremendous amounts of heat. So you know that there's attributes here, and you'd have to look at each situation. Your feedstocks, what sort of unit you have, and then what further processing is needed. You know, so it's hard really to state it a little bit more unless you want to add to that, Mark.
I didn't answer the very first part of the question. There is absolutely a market for the biofuels, syngas, even wood vinegar that comes out of this process. Each one of those byproducts has a different marketplace, but there is very much a push for utilizing the heat and or other attributes of the process to create electricity, renewable electricity, and feed that into the grid, or even taking that a step further with these processes, we can create green hydrogen. And there's a big push for that. There is a very big market for this. If you are doing it with the right equipment in the right ways, there are tax credits that are being given to the production of the energy and also the investment into the equipment to produce this type of an operation. But those are on the scale of 20, 30, 50, $60 million. So those really ramp up. But yeah, there's definitely a push for this, and it's absolutely where the market can see pyrolysis and gasification going.
Yeah, that is where it's headed, Mark. And in fact, as mentioned, the heat is significant, and that heat can be captured and fed back in pre-processing or pre-drying that feedstock. So if you're using a woody species, for instance, depending on the moisture content or some kind of sludge or something that it needs drying, then that heat can then be fed ahead in that to get it drier to the point to where it can run through.
That's great. Amanda? Yeah.
Yeah, great. Okay, this next one is a two-part question and then a comment. What price are you seeing biochar go for in the market? We are generating biochar from different sources. Testing it is expensive. What labs are the best to test your biochar? And then the comment is, it is important to note that costs for certification so you can sell carbon credits are really high.
Yeah, they are. Let's hit the price.
I can
first.
repeat the two questions.
Yeah,
if
no,
that's
I actually can see them, so I didn't realize
Oh,
I had
perfect.
access to see them, so that's great. The cost, the price for the biochar on a per ton basis is a function of a number of variables. One of the biggest challenges, being really frank here, we've been running at this for about 3 years with the early idea of, hey, we see and still do utilization of certified biochar to create those carbon credits to help offset the emissions and the carbon footprint of operations for oil and gas. We think that's there. If you want a carbon credit tied to your biochar, you're adding the value of that carbon credit onto the value of the ton of biochar as a measurement of sale. So if you have a process that's creating a certified biochar, and depending on the consistency and quality of that manufacturer, which is another really, really important variable to work towards and solve for, is consistency. The industry is emerging, and we're really just now starting to scale up to where we have consistency in producers' output. But those are two critical variables in what you might be able to command for the biochar. We are seeing $300 a ton to, we've heard folks that are selling really high level at over $1,000 a ton. I've even heard $2,000 a ton. I have no idea who would be paying that at this point, unless you're taking it to some other end use that has that much more value. So economics in this space are challenging. But getting better and better. The more supply that we see hit the market that's non-certifiable, the non-certified biochars are probably going to be struggling with price degradation over the next year or two until supply and demand kind of catch up. Emerging industries are really challenging, and oversupply is an issue that we see now, but that's fast changing. So we could be seeing that whole scenario flip within the next year or two, depending on how many folks really start adopting the use of biochar for different applications. So hopefully that helps with some of it. Testing is expensive. We've been blessed to work with some universities. So we've had the ability to have some universities do our biochar testing. There is a couple that we've used, John. I don't know if those are
well, yeah, and that area needs to be further developed as well. I reached out to one of the biggest testing labs, environmental, mostly for byproduct type testing, and they're just getting into it. So it's got a ways to go. The universities have been kind and good to us and have done some of that testing, you know, in Indiana University, like, you know, Mark has mentioned, and has been good. But you know, you got to have that sort of relationship with them, and you know, we're providing feedstocks for that testing and so on. So I know Eurofins is working on it as well. Those who have been in the environmental field probably know them as Test America. I can provide a contact there if you want something tested, but again, they're just kind of getting into it here. So, but they have great capability, and they are across America. And in fact, they're tied to the biggest lab in the world, I think, and is based out of Europe. But that's
Amanda,
an area we got to further develop, you know, that this level of testing that's needed now to take it to this technical degree, it needs to develop more.
Yeah, I was going to suggest to Amanda, we might be able to follow up with that question with, there's another company, I can't think of the name of it off the top of my head, that we might be able to refer that's a little more local, I think. Well, depending on where that individual's located. But happy to come up with that name and try to share that through the various channels so we can try to get that answer to you. So yeah, important to note that it is really high. And to John's point, yeah, we have to get that price down. Mike, Amanda, so Mike, you've come off.
Yeah, there might be one or two more questions we didn't get to. We can certainly follow up with that. We've got the contact information for those. And yeah, wonderful discussion. I think, you know, my takeaway, one of the primary takeaways I get with this total system approach, it really points to the complexity of so many different factors. You know, it's not just, you're not just talking about feedstocks, you're not just talking about siting of facilities, you're not just talking about potential applications and carbon markets. It's so many different factors folded in there. Standards, certification, all really, really important factors there that you point to. And you know, the good news for me anyways, that I see is that you know, as the industry is evolving, and you know, we've got great partners with USBI, IBI, and other similar groups that we're kind of working together. And I think it really points to what we're trying to do here at GLBN is education and collaboration. So I really, if our attendees here have one takeaway, perhaps it would be to reach out to us, to help us collaborate, help drive the activities that we're doing, so we can help make these interconnections. It's one of the value added that I hope we can bring to that thing. So thank you, guys. That was really interesting. I'm going to kind of jump on here unless there's Amanda, is there anything else that we need to?
Nope, just a few more questions in the chat, but I got those, and we can follow up with an email on those. So okay. I think we're ready for finishing slides.
Are you seeing my screen? Are you seeing my notes or what?
Not seeing anything yet, just seeing you.
Oh.
Okay, yep, and then just click the display settings and it'll go into slide form. Perfect.
Okay, you got it?
Got it.
Thank you so much. And again, thank you, John and Mark. Really a great kickoff to our Spotlight series. I really appreciate it. So we do have a couple minutes left. I wanted to take this opportunity to kind of let everyone know about our existence and kind of what we're trying to do here at Great Lakes Biochar Network. We have, I've already alluded to it, but we have two fundamental missions here. Is one to educate, and the other is to provide these networking opportunities. That's kind of our two driving forces. Our mission statement, as it shows, aims to be a centralized hub for relevant biochar information in the Great Lakes region. And so we are working to be a purveyor of good, solid, science-based biochar information and battling misinformation. And so and then as far as our collaboration work, we're relying on you all to let us know. So hopefully that this helps promote our missions, and hopefully future events will as well. A couple other things about us here at GLBN. It's myself and Amanda, and then we also have an advisory team, which is really nice. They've kind of a diverse group that have expertise in a variety of biochar areas. They help provide program direction for us, and they also provide great technical resources. So we have these folks at our disposal to bounce ideas off or ask questions and things like that. So some of the questions we come in often will go to one or a number of these individuals. Probably also point out that our group here is supported through funding provided through a program called Project Green, and also through funds provided through the Michigan Department of Natural Resources. I wanted to let everyone know that one of the things Amanda and I have been trying to do is expand our products that we do to communicate and to educate. And so we've got some work to do. We're up in the process of upgrading our Great Lakes Biochar website, and I would point to this. We will certainly have we'll have a recording of this here posted to our website, and I think Amanda said we'll also have it on our YouTube channels and things like that. So please check us out. Check out our website there. Two things I want to point to that we're working on right now. This kind of things we're working on would be we're still involved in encouraging people to complete what we're calling a social network survey. It's intended for the stakeholders, a variety of stakeholders across the spectrum of biochar practitioners. So we're still trying to solicit people to complete our survey. And if you haven't done so already, I would encourage you to please go in there and check it out and fill it out. We'd really appreciate it. The other thing, hot off the presses, thank you, Amanda, is our directory. It's something we know that we've been trying to get done for a while, and we're developing a biochar directory, and you can check it out. You can find it on our website. It's just right there. Click on it, and if you are interested in being included on our directory, and it's not just for biochar producers, it could be anyone that's involved, engaged in the industry, please reach out to us at glbn@msu.edu, and we would be happy to get your information and have your information posted on our directory. The other thing that we're really recognizing, and thanks to Amanda, because I'm older, and recognizing the value of our social media presence. It's a great tool for us to communicate and to educate. And so I'll encourage everybody to everyone to reach out to us and follow, and interact with us on these various social media platforms. I don't have our link to our YouTube channel, but that's up and going as well. So I'm sure if you search Great Lakes Biochar Network, you can find us that way as well. So with that, I want to again thank you, John and Mark. That very informative presentation. Thank you, Amanda, and thank you all for attending. One more comment about the Spotlight series. If you are interested in perhaps spotlighting something that you are engaged in that you feel will be educational or promote collaborations, please reach out to me at glbn.msu. And while the Spotlight series are intended, pretty much anyone can be involved with it via business, research, and whatever. If products or services are presented during the course of one of these Spotlight series, not necessarily endorsed or promoted by GLBN, but we just want to be education. So please reach out to me at this and connect with us here so that we can bring you more information. And we'll be following up with to all the people that registered. We'll be following up with a survey. We'd love to hear your comments on how we can better provide this type of information or these types of webinars, and we'd love for you to fill out our survey. So without further ado, I guess I will just go ahead and say thank you again, and keep touch base with us, and keep an eye out for future webinars.
Thank you, Michael. Thank you, Amanda.
Yeah,
Appreciate
thanks,
you joining us.
everybody.
Thanks, everybody. Yep. Holler if we can help.
Mhm.
We're here. Thanks, everybody. Take care. Bye-bye.